Hasana, can you hear me?
Yes, I can.
Okay. I'll be sending you the checkpoint test. Irham just yeah. Can thank you. Okay, so Irham, right? Is that correct pronunciation? Okay, so we actually started the syllabus for 2026. We started in November. So there was actually like 8 weeks of lessons that we did. And we covered trigonometry for AMF. Okay, have you done trigo in school? A little bit, right? Okay, so your school would have, maybe they will continue. Okay, so for here, right, since you missed, there's some recordings that I need you to follow. Okay, later I will text you. There's a group chat for us, and I will later add you to the group. Then there's some recordings I need to watch, but because that recording, right, was for when I did the lessons a few weeks back, the students had prior knowledge of trigo. Okay, so I went through a little bit faster because they already know trigo previously in Sec 3. Their school finished it, and also we did it last year in Sec 3. Okay, so we went through at a faster pace, but never mind, you try to catch the recording. So for the next few weeks, right, there will be extra things for you to do to keep up. Okay, so number one will be number one is you have to try to keep track of, catch up the trigo part. Then we are actually moving on to the notes number 3, which is on differentiation. So in AMF, I got 3 big topics you have to really master to pass. And if these 3 you didn't master, they'll put down your grades. There's of course the Sec 3 topics, but then for the Sec 4 topics, is these 3 big topics. Okay, also trigo, differentiation, and integration. So we finished trigo already for the past 8 weeks. And last week we did a checkpoint test. So today I'm going through the checkpoint test with the other students. Then so you have to do 2 things. So if once I start differentiation, right, the new topic, you learn differentiation. At the same time, so there's recordings that I need you to watch. I will let you know to watch from which part to which part. So gradual. It's not like watch everything for 8 weeks worth of lessons, right? But probably every week, just one recording extra you have to watch. School resumed already, right? Yesterday. Today. Yesterday. Okay. So try to keep up. Were there any lessons yesterday? No. Hello, Ikari, is it? Ikari, you are coming for makeup, is it?
No,
You're here for a trial, or you're registered?
I'm registered.
Registered. Okay. So what lesson are you coming for?
A math,
AMF. Okay. How do I pronounce your name? Your name?
Ikari.
Ikari. Okay, got it. Okay, so I'm Coach Michael. I'll be your coach for this AMF. Ikari, you'll be sitting for O level this year? Yes, okay. Which school are you from, Ikari?
Crescent Girls School.
Which school? Taipei.
CGS.
Oh, okay. Right? Oh, okay. Same as Hassana, is it? Okay, just give me a moment. Let me just check. Hassana, just give me a moment as well, because uh, I'll be going through the checkpoint test today. There's a new student online, registered. Can you double check? Itu bukan makeup. Ya, bentar ya. EAKRY. This view. Okay. Oh, okay. Then, you didn't tell me. Hey, Ikari, you'll be on your makeup, is it? From you're at this center or you coming for a makeup lesson? Can you confirm? Hassan, I will send you in the meantime, right? I'll send you your I'll PM you your checkpoint test, okay? Ikari, just confirm whether you are actually coming for makeup or you're registered for this class. Is this your first lesson?
Yeah, I'm coming for makeup, but also I'm also registered here.
Yeah, so you're registered to the other branch, Woodlands, right? You didn't attend the Woodlands lesson, is it? So you're coming at the...
Yeah.
Okay. Yeah, so, okay, so first lesson. So, is this your first lesson?
I've had previous master math, A math lessons before.
Was it in
Like
December, November or not?
in December.
December, okay. So you are here for makeup because you didn't... Which day are you at? Which day is your class supposed to be?
Saturday. Wait,
Okay,
I'm not
what
sure.
time? Did you sit for the checkpoint test last week?
Yeah, I sat for it
Okay, so yeah, definitely you're not from my class. So when you, because today, right, your coach returned to you, are you a physical or online student?
online.
Online. So do you submitted your checkpoint test, correct?
Yep.
To your coach. So did your coach return back to you?
Not yet.
Not yet. So I don't have access to your checkpoint test. Maybe next week when you go back. What time is your slot?
Hold on.
Like normally you attend on in December, right? What time? Is it a Saturday also?
It was meant to be Sunday, but it changed
Oh,
recently.
Sunday. What time is it?
Um,
Is your coach? Okay.
the 10:40 to 12.
10:40, 10:45. Okay. So next week will you be attending the Sunday 10:45?
No, I think I'm attending this one.
You'll be this one, right? Then you have to transfer here. Okay. I'll inform the admin. So moving forward, you'll be attending this slot, is it?
Yeah.
Okay, then because sorry guys, the rest I just need to confirm. Okay, hold on. So I'll send you first. WhatsApp, okay? WhatsApp. Sorry, there's a bit of transfer. Yeah. Okay, Ikari, I don't have your physical worksheet, but just pay attention, okay? Yeah, today it will be going through, but I don't have your... So I've sent you the worksheet. Can you take a look? Okay. Irham and Ikari, I will just very quickly recap. Okay, see what you remember. Your school covered, maybe not the full three goal, but maybe some things you still can remember. Okay, but yeah, okay, thanks. So Irham, these two notes, right? Thank you. So these two notes, I will need you to follow up through the video recording. I will tell you, okay, this week, follow through this particular video, then fill up this page. Okay, can I Irham? Okay, guys, so we've started the actual year and we need to quickly go through the checkpoint test today. Okay, Ikri, since you set for the test, right? I need you to also let me know when you set for the test, was there anything that you have trouble with? Then I can go through as well. Because I don't have your physical copy. Okay, so let's take a look at one. Hasana, you saw your error. What is the error, Hasana? Okay, Irham, you look at this question number one. Do you think you know how to start if you are given this question? So I also want to get a feel of what you know, what you don't know. Yeah, it's okay. If you don't know, you forgot. Okay, you're not sure. Okay, okay. So, Ikari, you check this, right? Part one. Do you know if you recall when you did the test, do you face any problem with part one?
No.
No. Okay. So first of all, this is cosecant, right? Cosecant, right? Irham, just for your sake, we always look at the third letter, the third alphabet. So the third alphabet is an S, right? So cosecant will be 1 over sine theta. That's what they want to find. Okay. So later, right, in the notes, there will be this 1 over sine, 1 over cosine, 1 over tangent. So 1 over tangent is cotangent, 1 over cosine is secant. Okay, so just let me look through the notes. Where is this in the notes? Okay, never mind. I'll just cover. Okay, so this is the one. Then they say that it's acute. When it is acute, theta is acute. So first of all, when they say theta is acute, so Sana, so this is another problem. When they say theta is acute, which quadrant should it be in? When they say acute, are you familiar with the ASTC quadrant? When they say acute Irham, which quadrant will it be in? Ikari, which quadrant would this be in if they say it's acute? Ikari, what do you remember?
Um,
It's okay, just share.
first.
First one, acute is from 0 to 90. Okay, so from 0 to 90 is acute, which means all quadrant. Understand? So this is 0. Go this way. Can? Okay. So all quadrant is 0 to 90. So Hasana supposed to be drawn here. Okay. Your triangle with here is theta. Then we label because they say cosine is 3 out of 4. Okay. First of all, when they say cosine is positive, which two quadrant can it be in? Irham? All. Correct. Good, you remember. So it can be all and cosine, but then because they already say it's acute, then you don't have to figure out so much. It must be drawn in the all quadrant. Okay. So when you draw, right, then you have to label. Cosine is tua ka so. Do you remember tua ka so? Cosine is ka. Ka is adjacent. So adjacent is 3. Hypotenuse is 4. Okay. Now, if let's say I'm drawing in the cosine quadrant, okay, just take note. I just want to recap. If let's say it lies in this region, the one in highlighted here in orange, then the values here must be negative. Okay. For example, if I say tangent tangent theta is equals to 3 out of 4. Okay. And tangent theta is, if I were to draw it in tangent quadrant, this will be theta. And then must remember that the orange region must be negative because you know your y and x axis, this is to the left and to the bottom, right? This must be negative. So here, right, it's tangent is opposite. So -3, -4. When -3 divided by -4, that's how you get 3/4. Can I understand? Hasana, are you clear? This one? Okay, this one just extra like it's not part of the question. Just I want to recap only. Ikari, do you understand? So when you draw in this quadrant, these two orange part, right? Those length must be negative. Okay. So anyway, here back to our actual question. This triangle, right? We need to find the unknown length. So we got our hypotenuse, we got our adjacent length, we got to find our opposite length using Pythagoras theorem. So square root of 4 square minus 3 square. This part, do you understand? Pythagoras theorem is hypotenuse square minus the other square to give me this length. Okay, correct? Because A math student, I don't have to do the long way. A square plus B square equals to C square, there rearrange because we are A math, I just skip, okay? If you need me to slow down, just let me know. So here, obviously, this is not a whole number. So 4 square is 16, 3 square is 9. So 16 minus 9, there's a 7, square root 7. Is that right, Hasana? Square root 7? Okay, so square root 7 is the length here. Now, then we can start to answer the question. They want to find 1 over sine. So 1 over sine, right? Or cosecant theta, right? Let me just rewrite this. So cosecant theta equals to 1 over sine theta. So from the triangle here, sine will be opposite over hypotenuse. So opposite is square root 7. Oh, I'm sorry, wrong. 1 over square root 7 over 4. Do you understand how I got square root 7 over 4? Sine theta. Cosecant is 1 over sine theta, right? So I just find sine theta from the triangle. Okay, let me just remove this in case you get confused. Can you understand? So which means I just flip back the 4 over root 7. Okay. Now for surds, just do an extra step, which is to rationalize. We don't leave surds in the denominator. In Sec 3, we remember that when there's a surd in the denominator, we try to rationalize. Okay, so from here, right, we will get 4 root 7 over 7. Correct? Is this the correct answer, Hasana? Yes, okay, good, done. Hasana, for part 2, right? Sometimes if you don't simplify wherever possible, you may be penalized, but I didn't penalize you for part 2. Okay, so you got the full 2 marks, just be careful. Square root 9 is 3, right? Correct, yeah. Okay. Ikari, you okay, Ikari?
Yeah, sorry.
Okay, you got disconnected, is it? Okay, can Okay, so can check whether you have problem with 1 part 2 when you did the test. If yes, I'll go through. If not, I'll move on.
Oh, no, it's okay.
It was okay. Okay, so Irham, for part 2, the other students got it right. So I'm not going to go through part 2. Okay, so Hasana, good job. You got it right. I just want to highlight that 30, 45, and 60, right? They are the special angles. They are the special angles, right? That supposed to memorize. Let me show you in the notes. By right, need to memorize, but we use this calculator shortcut method. You have a calculator, you have, right? Okay. So I'll just show you, 3. So some schools, they will ask the students to memorize. By the way, just now the cosecant, all those things, right? Take note. Just look at the third letter. So secant is C, right? 1 over cosine. Cosecant, 1 over sine. Cotangent. Hasana, don't forget, cotangent can also be cosine over sine. Okay, your later part, you missed out on that. Okay, but never mind, later I go through you, okay? Irham, for your sake, right? This one is in notes 1, page page 8. Okay, but what I want to show you is this one, the shortcut. So by right, this table, this one is on page 2. Supposed to memorize. Ikari, do you know how to press calculator to get this? Or you have memorized?
I memorized.
You memorized well. Okay, so good job. You have memorized. For those who haven't memorized, I think I taught you the calculator method. Like for example, Irham, right? This is in degree. Do you know your calculator can change to degree and radians, right? Okay, so as you check if it's in degree mode, can you press cosine 30 and what do you see? Sorry guys, the rest, just hold on for a while. Correct. So the moment you see decimals, right? You can't change it. That's not what we want. We want you to express it in root form, surd form. So do you know how to change? So what you do, right? Because you press cosine 30, you get a decimal, you square it. So cosine 30 square, right? You press your calculator, you get what you get? 3 over 4, right? Which means if I want to find cosine 30, I square root the 3, square root the 4, which is 2. That's how they got. So you don't have to memorize this table. Okay, what is it? The triangle, is it? Yeah, so can also. Leave it up to you. I'm familiar with the triangle until I didn't bother with it anymore until now I forgot. So I just kept to the calculator method. Okay, so how I started out also the same. I memorized by heart. Then I find it's too tedious, so I memorized the triangle method. Then I realized the fastest is the calculator method. Just they got extra step lah. I got to be careful. If you find square, don't forget to square root. Okay. Okay, so this one is based on the special angle 30, 45, and 60. So back to the worksheet just now, right? The checkpoint test, you have to do that. Okay, because they say without using calculator, so you got to find insert form. That's all. Understand? Okay. So we'll move on to 2A. 2A, Hasana got it right? Okay. 2A, Ikari, when you did this, any difficulties you faced?
No, it's okay. But
Oh, okay. Ikari, you want to join the other, is it? You need to leave, is it?
yeah.
Yeah, okay, go ahead.
Okay, bye.
All right, bye-bye. Okay, so Hasana, you are clear, right? This one, Irham? Okay. So this one is proving also. Proving, right? You have this formula sheet given, eh? You have this formula sheet given, right? So our formula sheet is broken into 3 groups. You know, just now got the cosecant, cotangent. That one you have to memorize. But the one given in the formula sheet is broken down into 3 groups. The first group is known as the Pythagorean identities, the one with the square. Then we have our addition formula. And then we have our double angle formula. Understand? Okay. So addition formula normally make use of the special angles like 30, 45, and 60. So for example, if you see like cosine 105, then you know you got to change this to cosine 60 plus 45. Then you just apply the formula here, split it. So that's addition formula. But then for double angle, if you see like twice the angle, like you see 2A or 4A, you know you got to use double angle. Okay? And now later, you watch the recording, you will understand better. But anyway, we move on to that. We are done. Back to the checkpoint test. So 2A, you got it right, Hasana. You managed to solve for B? Let me check. Solve, yes. Okay, good. Do you know how to solve? Do you remember anything? Not really. Okay, no worries. Okay, can. Next will be show. Question 3, part 1. Okay, so 3, part 1, if you look carefully, right, 3, part 1 is double angle. Okay, so if you look here, it's double angle. Hold on. Okay. Okay. So then we can refer to the formula sheet. Okay, so if you look carefully at double angle formula, okay, something wrong with the iPad. Wait. Okay. Okay, never mind. We'll just refer. So here you see you got double angle, right? They want us to show the left side equals to the right side. Okay, so we see got 2x. The right side is a 1x. Then you know you have to make use of double angle formula, number 1. You also have to make use of the cosecant cotangent. Okay, so for cosecant, first step will be to change this to 1 over sine 2x. Cotangent, right, can be 1 over tangent, but can also be cosine over sine. Okay, so it does not have page 8, that one, right? Notes number 1. Tangent can also be equals to sine x over cosine x. So cotangent means 1 over tangent, right? It can also mean cosine x over sine x. Correct. So here, right, cotangent here, this particular cotangent, not sure should I change to 1 over tangent or 1 over, or should I change to this? So I look at the question here. Cotangent here is by itself, right, is okay, so I look at the formula. If I change to 1 over tangent 2x, tangent here cannot combine with this. I can't combine. If I want to combine, I need to make denominator the same, right? Yeah, I can't combine. So if I change it to cosine x over sine x version, I will be able to combine. So that's what I want to do. Cosine 2x over sine 2x. Okay, the angle must remain to as 2x. Okay, so this one will be, let me rewrite everything again. So I'll start with my left-hand side is equals to cosecant 2x plus cotangent 2x. Then I get this. Okay, so then now I can combine, right? 1 plus cosine 2x over sine 2x. I'm almost there. How I know I'm almost there? Because cotangent here, right, is cosine x over sine x. Oh wait, still far away. Sorry, still far away. Not yet. Okay, so what I'll do is I refer to the double angle formula. So for sine, right, let's refer to the double angle formula. Okay, so the formula or double angle, I change the sine one first. It's quite easy, can you see? So I get 2 sine 2x. Okay, why like that? So 2 sine x cosine x. Then for cosine, right? For cosine, I have 3 variation. Hasana, which one should we use? For cosine, can you see there's 3 variations? Okay, do you have this one, right? Is under in the notes, it's on page. Yeah, that one. Yeah. So we want to get denominator, we will just want to be left with sine x. Can you see the green part here? My denominator, so I have this as reference. I want my denominator to just be sine x, which means my numerator, right, must have sine cosine x for me to cancel this cosine. Do you understand? So you plan ahead. Like here, 1 plus cosine 2x, right? Cosine 2x, we want to change it to?
The third one.
Say again?
The third one.
Third one, third variation.
1 minus 2 sine square A.
1 minus 2, is it? Okay, we change to that. But if we change to that, then we don't get cosine. So we should change to the second one. Remember, we want a cosine to cancel out, right? So we get, do you understand? I want this second one instead. Okay, so 2 cosine square minus 1, then 1 plus minus 1 cancel out, right? Okay, I'll make it easier for you to see. Okay, so cosine square means I got 2 groups of cosine x, correct? I can cancel out. I cancel out, so then eventually I'll get just 1 group at the top, but then 2 and 2 also can cancel out. Okay, so I'll just cancel out here. 2 and 2 cancel. This one cancel here. Get it? So I'm just left with cosine x over sine x, which is what the question wants, cotangent x. Yeah, sure. Okay, I'll zoom out again. Can you look through and see if you have any questions to ask? Okay, don't worry. This one, 8 weeks. We had 8 weeks of lessons, 8 weeks of practice to do this. Later, before end of the lesson, you share with me your number, add you to the group, and then also while you do, just listen. Every week or every other week, there will be revision questions for us to practice. Okay, so you got to manage your time. I know you resume school, but AMF is a different. AMF is not like the other subjects already. You need the extra effort. So I'm helping you in prepare questions to help you improve faster. Okay. And Hasana, any question? No. Okay, so Hasana, for the next part is a hence question. For the hence question, first step correct, you switch. Okay, so Irham, this type of question, if it's a hence, we want to use back the previous part. So from the previous part, we got to use the show question, show part. Change this to the cotangent. Can see? According to the formula from the previous part, this is cotangent x. Yeah, so whenever it's a hence question, always use back the previous part. When it's a hence question, you use back the previous part, can be the intermediary steps or can also be the final equation. So currently we are doing the final equation. Okay, so if I replace this, I get half cotangent x equals to cosine x. Okay, so pay attention here. This is how we solve. So in trigo, there's also solving, there's proving, and there's the other one, and then there's also the solving part. So for solving, right, the first step is always to make it a single trigo function. Currently, we got cotangent and cosine, not the same. So cotangent, I can change it to 1 over tangent, but then I will still be left with two trigo function. So what I do, right, is I change it to cosine over sine. So cosine over sine means cosine x over 2 sine x. Okay. Because half 1 in the numerator, 2 in the denominator, so I put together one fraction. Okay. Okay. Next, right? I can cross multiply. I cross multiply better. Okay. So I got cosine x equals to 2 sine x cosine x. Now, if you notice, this is double angle formula. Don't bother to change it to double angle because our angle is x. Keep it to single angle. Understand? So what I want to do is I will bring everything to the right or everything to the left, factorize. Some students, they see this, they go and cancel cosine x. Cannot, because if you do that, you'll miss out that cosine x is equal to 0. Unless they say cosine x is not equal to 0, then yeah, you can cancel out. Okay, but now they didn't, so what you have to do is group them. So 2 sine x cosine, I bring everything to the right, minus cosine x equal to 0. The 0 I put on the other side. Then I want to factorize cosine x, 2 sine x minus 1 equal to 0. Okay, clear. Now, next, right, I can split. You know, like when after we factorize zero product, you know, in Sec 2 or Sec 3, we learn quadratic equation, we can split, right? in EMAF, cosine x. Remember, in EMAF, example, we got x plus 5 equal to 0. So we split become x equal to 0 or x plus 5, yeah. So we call it zero product, we can split. So we are using the same thing for EMAF here. Okay, so we can say cosine x equals to 0 or 2 sine x minus 1 equal to 0. I will rearrange. Okay, so I rearrange the 1 bring over sine x equals to half. Okay, so I will show you the right side and the left side. Most of the time, we will be solving the one like from the right side. Okay, if you see your trigo function equals to these three numbers, 1, 0, or -1, you refer to sketch. Okay, so I'll do that later. I'll focus on the right side. So I will just go through with you. First step is to find our basic angle. Basic angle is alpha. You can write basic angle or you can use the symbol. Okay, no need to show both like this. Okay, so to find the basic angle, right, you must remember that you want to find sine inverse the positive value. So for example, if you got negative, you still want to press in your calculator sine inverse half. When you want to find basic angle, we are always taking the positive value. So sine inverse half. Do you understand? Again, first step is to find the basic angle. First step, sorry, is this. Single trigo function. Second step, find the basic angle. To find the basic angle, always positive. Take the positive value, even though you got negative. This is just a hypothetical, this is not the actual question, I'm just giving you example. Okay, so just take note. Think you remember? Next, after we find the basic angle, right, we press the calculator. Sine inverse half in degree. This one is in degree, is it? No, this is in pi. So when you do solving, you also have to keep a lookout on your domain. Your domain is in terms of pi. This means calculator must put in radian mode. When you see 90, 180, then you know it's a degree mode. But this one, you see the domain is pi, right? You know it's radian, which means I press my calculator in radian mode, I get a number. And this number I'm familiar with is actually pi over 6. If you can leave it in this form, will be better. Okay, how to get this form from the 0 point something, right? If you press your calculator, you can press your calculator, sine inverse 0.5 in radian, see what you get. Do you get like 0.523? Or you get pi over 6? Sine inverse half in radians, right? What do you get? 0.5. Correct. So how come I got pi over 6? So what you do is the answer that you got, you try to divide by pi. Can you divide by pi? When you divide by pi, you should get 1 over 6. So it means it's 1 over 6 pi over 6. Okay, a lot of things to absorb. Okay, but you just be patient slowly now. Hasana, you're familiar with this already, right? So find the basic angle. After find basic angle, we move on to the third step. As long as it is not this, right? We can find the basic angle and then we can move on to the third step, which is to draw your quadrant. So ask yourself here, we got ASTC quadrant, right? If sine is positive, look at this, sine is positive, which quadrant will it lie in? Correct. So it's either A or S. We have to find between 0 and pi. So from here, I can already write down my x value is pi over 6, which is my alpha. Second one, okay, Irham, you try. If the first one is pi over 6, this one, the second one will be this one, right? How do I find the second one? The angle in the sine quadrant will be 180, right? So 180 is pi. So pi minus pi over 6. Understand? Then we just next step simplify. So we got pi over 6. This one will be 5 pi over 6. Done. Okay. So the fourth step. So this is the fourth step. Just simplify that. Okay. So 3 steps here. Copy down first. Hasana, have you started your first lesson on Friday for AMF? Not yet. Okay. When, which days are your CCAs?
Mondays and Wednesdays.
Okay, what CCA are you in?
Choir.
Yeah, okay. Okay, can. So that one is if it's not 1, 0, and -1, right? So here we have cosine is equal to 0. So refer to sketch. The method is don't find basic angle method, refer to sketch. Okay, so sketch, you have to recall back how would a cosine curve look like? So cosine curve look like this. This is a cosine curve, cosine x curve. Okay, in degree, this is, or in radian, this is 2 pi. So halfway is pi. And we want to find when it is 0. 0 is the one that I will highlight in orange, no, not orange, pink. Can you see these 2 points? So that's what we want. If we press calculator cosine inverse 0, we only get one answer. That's why when you get 1, 0, and -1, best if you can sketch to confirm. Sometimes there's 2 answers, sometimes there's 3. Do you understand? So this is a cosine curve from 0 to 2 pi. What are the pink parts? If halfway is pi, what's halfway of pi? Pi over 2. What's in between pi and 2 pi? 3 pi over 2. So from here, we can conclude x is equals to pi over 2, 3 pi over 2. Then Hasana? Okay, I'll zoom out again. You all see if you have any question to ask. For Irham, just take note, there's 2 ways to solve. Most of the time is the right side version, where it's not 1, 0, -1. We solve using the basic angle method. And then the other one is if 0, 1, and -1, draw or refer to the sketch to confirm. Okay, and then what you can do is, since you got two answers, right, you can conclude lah. Therefore, x is equals to, but even if you didn't conclude, we'll still mark. Okay, so in total you have 4 answers. Just double check whether these lie within the domain. Domain say only find the value of x from 0 to pi inclusive. So let's double check. Everything is positive and didn't exceed pi. So yeah, correct. Okay, clear. Hasana, are you clear? Okay, we'll move on to the next one, which is part 1. This is the last one. So for the last one here, again, similar to cosecant 2x, cotangent 2x, cosecant 2x. Okay, so from here also, I know that one cosecant 2x from the previous part is equals to cotangent. Okay, from here, right, I will use this from the previous part to do the next one, the last part. Okay, but that one is 1. So this means there's 3 groups of this, right? So three groups means this is 3 cotangent theta. Do you understand my first step? I'm using part 1 formula. They say 1 cosecant 2x plus 1 cotangent 2x is 1 cotangent theta. So since now this is a 3 times of it, right? Can I understand, Hasana? My first step. Okay, again, without using calculator, find cosine. Okay, so definitely cotangent got to change to cosine already, because cotangent and cosine is related, right? It's cosine over sine. Cosecant is 1 over sine, so I'm almost there. Okay, again, try not to cancel out the sine theta, but because you may be penalized, especially if sine theta is equal to 0. It's not. Yeah. So what you can do is you cross multiply. So 3 cosine theta sine theta. Do you understand this type? Cross multiply. Okay, so this one just times, this one just times. Okay, Hasana, okay, right? Okay, then bring everything to the left again, then factorize. And then we can just focus on cosine. Okay, so sine theta equal to 0, or 3 cosine theta minus 2 equal to 0, then cosine theta equals to 2/3 shown. They didn't ask to solve for the angle, they just want to find what is cosine theta. 2/3, I got it. Okay, and the end of January, right? Starting this week, we will start on the new notes, which is the other topic. Okay, but end of every week, I will try to send you questions to practice on Trigo as well. And then end of January, I hope you manage to catch up, and then we can have a quiz also. Okay. Now for here, right, in this center, every term there will be a checkpoint test, and it will be tested whatever we have covered for that term. For example, like November and December, we did Trigo, so Trigo was tested. So January onwards, we'll be doing differentiation. So by end of Feb, before your weighted assessment 1, there should be a checkpoint test. So it should be differentiation tested like that. Okay. Yeah. Okay, but those things you can just see where you are at. At least your parents also know where you are at. Okay. Okay, any questions, Hasana? Are you clear? So Hasana, just take note a bit of your some math is knowing how to do is one. The other one is to minimize as much as possible your careless mistakes. Okay, yeah, especially like your first question. Okay, Ken? Okay, done for Trigo. So Irham, you just keep these notes. There will be some recordings that I will send you directly. Then yeah, I will let you know which one to refer. Okay, so just on your end, just find time to view the recordings. Okay, understand we are in Sec 4 busy, right? What subjects are you taking this year? Oh, triple science. All pure lah. Do you remember what you got for your EOY, end of year Sec 3 for AMF? 78%. Oh, that's good. Okay, but okay, then hopefully you can keep up. You can catch up. All right, can. Were you in the Sana, just hold on for a while. Got disconnected. Okay, Hasana, do you have notes number 3? Then, do you have notes number 3? Do you have notes number 3?
I do have it.
Okay, just hold on then. Just hold on for a sec. Got disconnected. We will try to rejoin. You don't have note 3, is it? Hasana, is it?
I have.
You have it. Okay. Can. Do you remember if your school covered differentiation?
No, my school hasn't covered it yet.
Okay. Wait there. Give me a moment. Okay, let's take a 5 minutes break, Hasana. Let's take a 5 minutes break. Then later we having some technical difficulties here. 5 minutes break later we continue. Okay. All right. Okay, thanks. The top back. Hang on. Does it happen before? I'm troubleshooting, but has it happened before?
The screen is still up, but
Yes, but not responding. But okay, I restarted already, but
never happened before.
never happened before. Okay, no worries. Okay. Yeah. Okay. Continue from here. Test, test. Test, test. Okay, can. We'll just continue from here. Differentiation, okay? So, Hasana can hear me, right?
Yes.
Okay. Okay, we'll continue with differentiation. And over the weeks, we will still recap on three goals. Okay, finally it's back. Okay, sorry about that. Let's take a look at differentiation. So we'll move on to the differentiation. Hassan, you got these notes, right? Okay, can. So let's take a look here. So differentiation is something new. You have never covered it before. So today is the first lesson for this. You just try to pick up whatever we can. Okay. So differentiation, there's another 8 weeks maybe, or 6 weeks before we can finish this differentiation. Then we move on to integration. Okay. So hopefully we can really get things on time, so that we got more time to revise for prelims. So I mentioned like trigo, then differentiation, then integration, then got one last topic that is related to circles. That one is just a small topic. But then after that, it's just revision from Sec 3 topics. Okay? Okay, so today we will be looking at the differentiation. So differentiation, right, is just changing some algebraic expression into another form. Okay, so how we do it is, for example, let's look at this power rule. Okay, so we look at this thing called power rule. When we differentiate, right, on page 1, you all on page 1, right? Oh, sorry, page 2. If our power is n, when after differentiation, it becomes n to the power of -1. Differentiation power always -1, no matter what value it is. So n here is just a random number. It can be 10. So if 10 after differentiation become 9. If it's like 1.5, after differentiation it becomes 0.5. Do you understand? Differentiation always minus power by 1. You follow? Okay. So n here become n, right? X still remain. Okay, so the power -1, right? Then what is going to happen is this n will times the a. So for example, it become n times a. So we become a n x to the power n minus 1. Okay, okay, maybe like this you don't really understand, right? Because it all a n, it's not something that you're familiar with. Let me give you a simple one. That's why I told you x to the power of 10, for example. If I have got 3x to the power of 10, when I differentiate, the 10 becomes a 9, and my 10 will times by 3. So 3 times 10, or 10 times 3 lah. So equals to 30x to the power of 9. This is the example. Okay, I want you to look at the actual example, and I want you to also can you understand? Whatever power that you have, -1, that power must bring down and multiply the coefficient of x. That's differentiation. Can understand roughly? One more example. One more example. Let's say I have y is equals to 2x to the power of 3. So dy over dx, right, is just differentiate. Okay, this symbol is differentiate y with respect to x. I'll explain that later. But this is the presentation. If I want to differentiate, I must write dy over dx. Yeah. Now, Irham, you want to try? What happened to 3? X cubed become x to the power of 2. Okay. And then now, right, the 3 must multiply by 2. So eventually you get 6x squared. How you think you can understand? Hasana, you roughly understand? Can, right? Okay. So what we want to do is we want to try practice number 1. For practice number 1, so same thing here. We want to say that we want to differentiate, we must change the form to dy over dx. Okay, then become 2 times 7 over 5 x to the power of 2 minus 1 which is 1. So my final answer will be this. Can follow, Hasana? Okay. Irham, okay. Okay. So one thing to take note of is also when you want to do differentiation, right? Your power of x, your x must be in index form. For example, if you see here square root is x to the power of half. You got to express it in power form first, then you differentiate. So this is what this is referring to. Students, right, they must always express it in power form. So when you see square root, change it to the power form first. Okay, so square root is the power of half. Cube root is to the power of 1/3. You have to recall back your indices. Okay, so here, don't differentiate yet, change its form. So it is still y, but then now becomes 6 bracket x cubed to the power of half, right? I'll skip a step, becomes 3/2. Okay, I want you to see if you understand how I went from here to here. Do you understand how I go from here, changing its form, square root? Hasana, do you understand? Yes. Okay. Irham, you understand? Then only differentiate. When you want to differentiate, then you must write this. Differentiate of y with respect to x. So 3/2 must times 6. And then 3/2 must minus 1. So 3/2 is 1.5, right? 1.5 minus 1 is half. Then I simplify, I will get 18 divided by 2, 9x to the power of half. Need to change back to square root or not? No need. Can follow everyone. Okay, differentiation got different types. This is algebra. Later we need to differentiate exponential. We need to differentiate ln. We need to differentiate trigo. All have different rules. Algebra is the easiest. Do you understand part 1 and part 2? Can? Don't understand, just ask. Okay, I'll slow down. Can? Irham? Okay. Next one. Not all the time, right? Your expression is in terms of y, like y equals to something for part 1 and part 2, right? Sometimes it's in terms of fx. Fx is the function, the expression. So we want to differentiate. We use this symbol, f prime. Wait, Okay, so if we want to express, right, we need to make sure it is in terms of, sorry, so we put f. Okay, thanks. Let's try it with that. Never mind. I take the pen from the other side. Previous coach tak charge Apple Pencil. Borrow, eh? Let's see whether can. Sorry, guys. Okay. Okay, can. Sorry, for the delay. Today got a lot of delays. Okay, so when we want to, if we got y and then we want to differentiate, we put dy over dx, correct? But then if we are given fx, we put f prime. Can you see this? Can you see? That means differentiate x. Just a different form. Okay, so the method is still the same. Okay, but sorry, before that, don't differentiate first. Okay, don't differentiate first. Why? Because I need to change its form. Okay, don't differentiate first because whenever we want to differentiate, right, x, if possible, x be in the numerator. Yeah. Yeah, go and charge here lah. Then I'm using this. Yeah, can.
Thank you.
Okay, so the emphasis is whenever we want to differentiate, right, we need to make sure x is in the numerator, preferably. So for example here, still fx, haven't differentiated yet. I must bring my x up. So become x to the power minus 4. Then I can proceed to differentiate. Do you understand? If I keep it in the denominator, then difficult to differentiate. I need to bring it up first. Okay, if you look carefully here, all of the x are in the numerator. Then I can differentiate. Are you clear, Asana? Okay. Then after I differentiate, it becomes -4 times this. And then -4 need to -1. That's why now become -5. So then just simplify. So negative and negative positive 32 over 3 x to the power -5. Okay, I want you to take a look at part 3 and see if you understand. Can Hasana can keep up? Okay, so you see square root, put it in power form. You see in the denominator, put it in the numerator first, then differentiate. So until you differentiate, don't write this step. Keep it as fx first because haven't differentiate yet. Okay, clear? Like the one before also. Haven't differentiate, keep it as y. After differentiate, then dy over dx. Can? Okay. If you see one bar, right, later, if you see one prime like this, means differentiate once. Later, you'll start to see when you have double, means differentiate another time. Okay, but that one later on. I'm just telling you, if you see one line means differentiate once, you see two lines means differentiate again. Okay? Okay, now we move on to the next one, y. I mean part 4. Okay, if you see a constant, right, 12 like this, y equals to 12, actually is, there's x, but to the power of 0. Okay, x to the power of 0 is 1, right? Yeah. Okay, but wait, let me see. So, okay, so just remember, it must be, there must be an x. So if there's no x, right, when you differentiate, is 0. So let's say there's no x, then 0. Can follow? Okay. Okay, then we look at the next one, the constant rule. Yeah, so this is the constant rule where differentiate, if y equals to k being a number, a constant is a number. So when y equals to a number, your first derivative, right, your dy dx is 0. So it doesn't matter what number. So if y equals to any number, 1000, you differentiate, get 0. If y equals to -5, differentiate, you get 0. You know what I mean? As long it is a constant, you will always get 0. Correct. Okay. Next, we move on to practice number 2. Practice number 2 makes use of this lah. Okay, if you see this, because it's in terms of U, V, right? Okay, this one more to JC or JC level, then we need to know the steps like this. But another way to look at it is, if you see a group of algebraic expression, just do it individually. If you want to differentiate, just differentiate individually. This means differentiate 5x to the power of 5 first, for example. So I write dy over dx equals to the derivative of this. Okay, so maybe Hasana, you want to try? When you differentiate this, what will you get?
25x to the power of 4.
Correct. Irham, your turn. How about you differentiate positive 3x squared? What will you get? Done. Do you understand? So if you got 3 terms, 4 terms, 5 terms, just differentiate individually. Then must always remember, is square root or cube root, make it in the power form. If it's in the denominator, bring it to the numerator. Then you differentiate. Are you clear? Okay? So this is just what it means lah. This whole thing that you see here, the sum rule and difference rule, it just means go and differentiate everything equally, individually, then combine them. Okay, so here again, gx. So if I want to differentiate this, g with one line here, g prime. Okay, so this one become 14x to the power of 6 minus 24x squared plus 5. Because x to the power 1 minus 0, sorry, 1 minus 1 is 0, right? X to the power 0 is 1. That's why it's 5. Then minus 11, I get 0. Can follow? Okay? Are you clear? Any questions? No, eh? Hasana, okay? We'll move on to the next one. Remember the rule, if it's in the denominator, bring it up. If it's square root, make it to the power of half, and so on. So this one, I don't differentiate first, I change its form. Again, I'm only moving up the x, not the 3. 3 remain. So it should give x to the power of minus 2. Okay? Okay, so then square root of x, I know is x to the power of half. When I bring it up, it becomes x to the power of minus half. And then we got the next one. This one need to combine using indices lah. So x to the power 1 divided by x to the power 1 over 3. Final answer is x to the power of 2 over 3. Can understand? You all understand? Correct, because over is divide, right? Yeah, so I recall my indices law, divide power minus. That's why 1 minus 1 over 3 get 2 over 3. You all okay? If you need me to explain, just let me know, okay? Because I assume you know your E-math very well. I skip steps, okay? So from here, I will get 6 x to the power of 2 over 3. Then I'm ready to differentiate. Just now, not in the correct form, don't differentiate yet. Next, then I can differentiate dy over dx. So here, negative 2 times 4, negative 8 over 3, x to the power of minus 3. And then negative half times 8, so negative 4, x to the power of minus, so minus half minus 1, minus 3 over 2. Okay, then later 2 over 3 times 6, negative 6, so it's negative 12 over 4. 4x. Okay, so all the powers minus 1, and then all the powers must times the coefficient of the algebra lah. Okay, you all get a rough idea how this is? Can follow, Hasana? Okay, can all right. Okay, how about for part 4? You all okay, right? How about for part 4? You all do homework? Can? So this one for today's is 3 Gen, homework for 3 Gen. Okay, you all do this. Remember, the rule is bring up the x first or simplify first. Like you start to see here, can simplify, right? Simplify first, then only differentiate. Okay, so that one do as homework. Now I move on to the next page. Okay. Now in the next page, right, they give it in this fx form. So no worries. But then the one on the right side, right, is not simplified. When you see a single term denominator, you can split it. When you see a single term denominator, you can split it into 3 fractions. I got 3 terms, right? So I can split it into 3 different fractions, okay? See how I will do it. First of all, my square root x become x to the power half. Can understand my first step? I split it into 3 different terms, then I can differentiate individually. Okay, so this is still fx and still haven't simplified. Okay, so here I do my indices x squared, so 2 minus half is 1.5. 1.5 is 3 over 2. Normally for powers, we just leave it in the improper. Then we have x to the power of half. Then for the 4, right, I need to bring it up. Because there's no x to simplify, I have to bring it up. It becomes 4x to the power minus half. Again, this is still fx. Haven't differentiated yet. Can follow? I just change its form first. Make it in the right form, ready to differentiate. Can follow, right? Now then I want to differentiate. So f prime, so 3 over 2 times 2, 3x to the power of half. Half bring down, so I got minus half. Negative half bring down, become positive 2, x to the power minus 3 over 2. Can keep up so far? Still introduction, just basic algebra differentiation. Do you think you understand V? V is 3, 4, 5. Part 5, do you all understand part 5? Hasena, do you understand? If I'm going too fast, just stop me, let me know. Okay? Can, right? Okay. If you understand part 5, which means VI, you should be able to do as homework. Same concept, split it into 3 fractions, simplify, then find h prime x. H prime x lah, okay? Can? Then next week, right, we will continue with chain rule, where it's a group already. Anyone have any questions? No. Okay. Also, before we end, right, I want you to take a look at this box on the right side. So just now, remember, I split, because it's a single denominator, I can split. But it's not, if it's the other way around, single numerator, then cannot do this. I can only split if it's a single denominator, not single numerator. It doesn't work that way. Okay, can? Okay, all right, good. So just take note. Later I will before end I get your number first, Irham. Okay, Hasana, any questions? Not we end here. Then I'll see you guys next week. Don't forget to do the 2 questions. Okay, Ken? All right, bye-bye. Okay, Irham, I need to get your number. I'll add you to the group. Wait,